Cell potential practice problem 1. So we have a tin electrode and a nickel electrode. We're given standard reduction potentials for both tin and nickel. And we're asked to identify and determine a number of things. So step 1, identify the cathode and anode. So first of all, the more negative the reduction potential, that's the one that undergoes oxidation, which is therefore the anode, and reduction occurs at the cathode. So the cathode is the tin, the anode is the nickel. Okay, so we did this and this. Then it says determine the oxidation half reaction and the reduction half reaction, which we've done here. We've labeled oxidation and reduction here, but we need to flip the oxidation reaction to show the loss of the electrons. So nickel and then nickel 2 plus and 2 electrons. Okay, then we need to combine our two reactions and make sure it's balanced. And so both of these reactions are already balanced for matter, and we see a gain of 2 electrons and a loss of 2 electrons. So it's also already balanced for charge. So we can just write this sum of the reduction and oxidation reactions. Okay, and remembering that the number of electrons gained is equal to the number of electrons lost. Okay, and then the E cell. The E cell is the standard reduction potential of the cathode minus the anode. So the cathode is minus 0.14 minus the anode minus 0.25. And so we get an E cell of, this is 25 minus 14, so 0.11 volts. Okay, so we've answered all of our questions. We are done. Cell potential practice problem 2. So again, here we're going to identify a number of things and then determine some things. So I'm going to look here. I have a tin and an iron electrode, and I have standard reduction potentials for both. Remember that the more positive the reduction potential is where reduction occurs. That means oxidation occurs here. Reduction occurs at the cathode, oxidation occurs at the anode. Okay, so the anode is the tin and the cathode is the iron. Okay, then the oxidation half reaction and the reduction half reaction. So the reduction half reaction, that of gaining electrons, is already written for me. But the oxidation half reaction, I need to flip it to show the loss of the 2 electrons. So tin, Sn2 plus 2 electrons. Okay. The other problem I have here is that I have 3 electrons gained and only 2 lost. So I'm going to multiply my reduction reaction by 2 and my oxidation reaction by 3 in order to have a net gain and loss of 6 electrons. So I can put those two things together. I have 2Fe, 3 plus 3 Sn, give me 2Fe plus 3 Sn, 2 plus. So I've got my oxidation half reaction and my combined reaction. And then to find E cell, I just subtract the standard reduction potential for the cathode, which is 0.77, minus the anode, negative 0.14. Okay, here we get 0.91 volts.